Let's take a look at this week's review questions. Question: how did Lamarck's theory of evolution differ from Darwin's and Wallace's? Lamarck provided one of the first theories of evolution, a very important and notable feat. His inheritance of acquired characteristics, while incorrect, did provide important information for Darwin and Wallace's theory. The idea of inheritance was part of the foundation in both theories. However, Lamarck suggested that traits acquired during life were passed on. Darwin and Wallace suggested that biological traits were passed from parent to offspring, but these were unrelated to what was acquired during life. In both cases, these scientists were well ahead of their times. They were incorporating the concept of inheritance before studies of inheritance and genetics had begun. Question: how did Cuvier and Lyell contribute to the groundwork of evolution? George Cuvier was instrumental in illustrating the potential of fossils as a tool to investigate extinct species of plants and animals. As a pioneer in the field of paleontology and comparative anatomy, Cuvier was able to reconstruct the biology and behavior of extinct species based on their fossilized remains. His analysis of fossils provided Darwin the foundational concepts of variation in the fossil record and extinction. Charles Lyell, a geologist, rediscovered the concept of uniformitarianism, the predominant theory of modern geology. Uniformitarianism, or gradualism, suggested that various natural processes that operate in the modern world are the same as the processes that occurred in the past. This theory gave Darwin the foundation of a dynamic Earth. The Earth and its environments changed throughout Earth's history and continue to change today. Question: what concepts of Malthus did Darwin use in developing his theory of natural selection? Darwin relied heavily on the ideas originally put forth by Thomas Malthus. Malthus's suggestions about population size and its relationship to resources proved to be a key concept on which Darwin built his theory of evolution through natural selection. Malthus observed that more offspring are produced than can possibly survive, thereby maintaining a population's size over time. This limitation of population size is directly related to the available resources, most importantly, the food supply. Since there are more offspring produced than the food supply can possibly support, competition results. The winners of this competition have access to the food supply and thus are more likely to survive to reproductive age. Finally, Malthus noted that the ability to survive, successfully compete, and reproduce varies among individuals. In other words, variation exists. Darwin used these ideas by suggesting that individuals with more advantageous traits enable them to survive and reproduce more successfully than those individuals with less favorable traits. Question: how does Mendelian inheritance work and why is it so important? The pea plant experiments conducted by Gregor Mendel provided new understanding of inheritance of simple traits. Mendelian inheritance counters the earlier prevailing notion of blending inheritance, in which the offspring were simply a combination of the parent's traits. Mendelian inheritance introduced the concept of inheritance of discrete physical units. Mendel observed that there was no blending of traits, but that either one form or the other was expressed. Mendelian inheritance was very important because it provided the foundation for later research, especially with the discovery of genes, the discrete physical unit to which Mendel was referring. In addition, Mendelian inheritance helped to explain the mechanisms of evolution through natural selection. Question: what is evolutionary synthesis? Evolutionary synthesis is a unified theory that takes Darwin's theory of evolution through natural selection and combines it with Mendel's theory of inheritance. While Darwin's theory demonstrated the mechanism of evolution in the form of natural selection, it was the foundational concept of Mendel's work that showed how these traits were passed from generation to generation. Darwin understood and showed in his writings that physical traits were passed from parent to offspring, but he had limited understanding of exactly how these traits passed and how to predict which traits would be expressed. Years later, the work of Mendel addressed this area.